Welcome to another Lightblade Learning Lab. Today we're going to tackle one or two more slightly advanced tools. On the last session we dealt with the standard drawing tools, and today we're going to probably use some of those tools as a basis for some of the stuff that we're going to manipulate and deal with. We did actually do a little bit with horizontal mirrors and vertical mirrors, because we did that, if you remember, when we put some text on the screen. We were able to show that we can easily just flip that text with this tool, which is a horizontal mirror, and flip it again and it turns the text back again. And we could do the same vertically. We could check it, click it. The last time we used this, I'm sure that we moved that from there to the top right hand corner. So now I've got my center position, my handle, if you like, for this piece of text is now sitting up here with the green square. So any location that I now make should be based around this corner here and not the center of the object. Now you can see clearly that this piece of text is not set into the center of the screen, and over here we've got a function which basically says center data. So if you've got bits and pieces that you want to accurately set on your table, you should be able to press this button, and it's a 600 wide table, and at 300 millimeters, which is here, and 200 millimeters, which is here, it's put the center handle. So it's actually located the piece of text on the central point of the object, not on its location handle, which is up here. If you remember, look, we set the location handle for precision positioning up there. So there's yet another thing that's going on here with positioning, which is overriding everything that we've already set, but it's a useful function. Now I'm going to draw a circle. I'm going to put a handle around it, and now we're going to size the circle, and we'll make it 20 millimeters diameter. We've got the lock on, so we only need to change one of these dimensions up here, and I'll change it to 20 millimeters. And what I'm going to try and do now is a matrix copy. Now basically what I get the opportunity to do here, it's an array copy, but the question is, how many copies do I want in X? Let's say we want 10 copies. Now the normal array system that you would get in a CAD system, and probably most drawing systems, will be from center to center. In other words, when you say you want these spaced 50 mil, it means 50 mil centers. No, in this case the X space is the space between the parts. So if you want 50 mil centers and we have got a 20 mil diameter, that means we've got 10, 10, we've got a 30 mil gap. So I'm going to have to put 30 mil in there for the spacing. And in Y, well, let's have 5. And we'll have those at 10 millimeter spacing. So that's one way that we can use this system. We've got an opportunity here to build the array from the bottom corner up, from this bottom corner up, from this top corner down, or from that top corner down. So this little handle here, if you look carefully at it, you'll see that there is a little indicator to show you which way your array is going to be built. Now because we've put our first one up here, it makes sense for me to have the datum up in that top left hand corner. So let's just see what happens. Sure enough, it does exactly what we thought it would do, and hopefully we should find that these are 50 mil centers between here. Now how can I do that, I wonder? How can I measure that? Yes, I suppose I could accurately move that to a position, which will be a position here, 10, 10. And there we go, look, it's moved to that position to 10 millimeters by 10 millimeters. Okay, so now that we've accurately positioned that corner, we can see that every one of these intersects here is coinciding with the center of a circle. And of course we can just count these, because I know that I made these 10 millimeter pitch. So that's 1, 2, 3, 4, 5. Yes, so we've got our 50 millimeters. But is there another way of doing it? Well, the only way that I can check two of them now is to say, well, let's 50mm centres plus 10, so that's 70mm, the length of that side. And sure enough, look, it says 70mm. That's what an array system does. It gets slightly cleverer than that, because if we just box this lot off, and there's our sample, we click on there, and basically, look, if I want 10 and I want 20, my expectation was that when I do bestrew and I specify that the width is, for example, as I said, 300 and the height is 200, it would automatically produce a spacing between them to suit 10 in X and 20 in Y. Hasn't done that. So it's not that clever. It needs me to tell it. So if I put 20mm spacing there and 20mm spacing here, let's just see what it says now. Bestrew. So we'll make the width 300 and we'll make the depth 200 and we'll say OK. Your demand means you can only have 7 circles by 5 circles. OK. Well, I suppose it might have some use. It just seems very, very hard work to get there. Anyway, you've seen it working. OK, so we've now covered every one of the tools down the side here. We've got all the standard filing systems at the top here with the import, export, do and undo. So let's stick a square on there. And we've got all these little array of magnifying glasses across the top here. What do they do? Well, the first one is basically a hand, which means something is going to move. But remember, this is a magnifying glass, a view on the table. This is not a view on the object itself. So when I press my left-hand mouse button, the object stays in the right place on the table, and what I'm doing, I'm viewing a different part of the table. Now you might say, well, that's not very useful, but we'll come back to that in a minute. The next one is a positive zoom. So if I click on here, just that corner, for example, look, the corner stays still, but I'm getting bigger and bigger and bigger. So always the middle magnifying glass in there will get you back to normal. If we now do this one, which is zoom out, I can put that on a corner and it will zoom out around where I place it. Back to the middle one. Now that view all is view all of the drawing, not view all of the table. So this middle one here, there, is show the page, which is basically show the table. But if I draw a circle on here as well, we shall be able to demonstrate what I mean. So if we do the show all, which is that one, view all, it just puts all of the objects that are there onto the screen. Okay, the middle one sets it back to normal, and then what we have the opportunity is show selected data. So that means that I can presumably do something like this. Okay, so there's not really any difficult functions along the top there with those magnifying glasses. The most useful one is the one that puts it back to show page, that one. But then again, if you've got a mouse with a scroll wheel on it and a switch on the scroll wheel, let me show you something. Let's just turn this back to a normal pointer. With a normal pointer, I can scroll out and I can scroll in where the pointer is. So if I put that right on the corner of that square, look, it will scroll in and out on the corner of that square. And then if I want to do a move, which remember was one of these glasses, if I hold down my mouse scroll wheel switch, I can move objects around anyway. And so why would I want to go and select that area when I can just put my scroll wheel on it and go straight into it? It's so much easier with the scroll wheel than it is with fiddling around with these functions up here, with one exception, which is the number, the middle one, click, which you always want to get it back to something normal. Now I don't think there's a great deal that we can do after we finish these magnifying glasses. Most of these other little functions along here are all to do with cutting and programming, and as we haven't done any of that yet, we can't really benefit from checking those out. Well, we shall tackle those a few at a time as we get to the appropriate point in the programming. So what we now need to do is take a quick look at these functions along here. Now these are all basically alignment and position functions. So, silly example, we've got an object here. If we want it to go into the top left hand corner of our table, we can send it there. If we want it to go into the top right or into the center of the table, that's all those do. So it sends the drawing to an appropriate place on the work table. Well, that was nice and easy, wasn't it? And sadly we have to keep going back and picking up every square every time. Just remember the last one that was drawn, which is this very small one. So if I now put these all together in a single block marquee, and we'll take a look at what happens when we start moving along these alignment. First of all, align left. Now that should be pretty straightforward. It should align everything to the left hand side of what? Well, the answer should be that it will align everything down here, because this is the last object drawn. Let's just check that out. There we go. So we'll do a Control Z to back that off again. We'll put them all into a group. And now we've got align right. So we have to assume that they will now all align down here. Fine. Control Z to put them all back. And now we've got align top, which should be pretty straightforward. I think we'll find out that we're going to align them all along here. They won't actually all box around here. They will just sit in a line across the page here like that. So that one should drop down the page and align up here. So let's just verify that. And there we go. Control Z. And this one should align at the bottom. So that was pretty straightforward. Okay, now we want them aligned on center, horizontal. So they should all basically line up along this line here, which they do. And then finally, we can line them up in the other direction. As a set of individual alignments, it's probably rare that you want to use them as individuals. But bear in mind we've just done a central alignment in one plane. There's no reason why we can't press the next one back and do a central horizontal. And there we go. We've got all those squares nice and concentrically lined up, if you can call concentric to do with a square. That was a nice easy block to look at. Let's now do Control Z to get them undone and back into that random position. If I delete those, it'll be much easier to see what's going on. Control copy, Control V, Control V, Control V, Control V, Control V, Control V. Now the last one that I copied was that one. I'll now marquee that whole set and we'll do this. And now you can see, and I will line them up in the other plane and you can see what's happened. We've got them all nicely spaced between the first and the last one, and they're all nicely lined up with a combination of some of these controls at the top here. So I've now got those two like that. If I box this whole lot in and I ask for width, it's changed those two so that they're the same width as the master one, which is this one at the top here. If I press the next one, they've all got to be boxed. And this is the last one that we had. So what I should do actually, let me change this last one so that it is just slightly taller than all the others, and this one's far too tall. So we'll box them in, and we'll now change the height, and we would expect the height of all of those to copy the top one, and there it is. And if we change this one to that shape, this is the master, remember. If I press size, they all become the same size. Okay, well I think we've dealt with all of these alignment tools except this last little block at the end here. Now this has been a bit of a mystery, but the official word from Ruida is they don't do anything at the moment. They're put there for some future functionality, I think is the official words. So don't get too stressed about these at the moment. One day we shall find out what they do. We're now going to go back and we're going to revisit something we touched before, which is text. Now when I drag a piece of text onto the page and click, the first thing that opens is the text box. And we've had the opportunity to put just standard text in here, and then we went through the justification process, etc., etc. But there is another, what looks like a potentially very clever and powerful feature built into this text window. And if you tick the enable variable text box just here, all of a sudden we get some extra features come in, and we can do a clock. We can do it down to seconds. Apply, and it tells me here live on the screen. Well, it's not live, but if I click apply again, you'll see that it changes from 45 to 54 to 56. So undoubtedly it's getting its time information from the PC itself. Let's just say you're marking the package on some food product which has got a sell-by date, or you need to know when it was actually processed. This looks potentially very handy because it could be sell-by dates, it could be manufacturing times. This PC at the moment is not connected to the machine. If I do apply, OK, and there we have 10:51:49. I can save that to a U file onto a memory stick and take it out to the machine. And my expectation when I first used this software was that the machine is clever enough to know that it's going to store that data as some sort of time variable that the machine can look for. I would guess that somewhere built into the controller is a time clock, because it monitors hours of use of the machine and various other things. So my expectation was that when I took this out to the machine and plugged it in, when I etched my first program, it would say 10:59:27. What did it say? What you see on the screen here. It's frozen in time. So that's not a lot of good. So my next reaction was, it's because I haven't connected it up to the machine via a USB connection. So just to prove that my assumption was correct, and that downloading a program via the USB cable connected directly to a laptop would update this time variable constantly because it was connected to a PC. Sadly, it didn't work that way. The only way to keep your time updated is if you've got your program live on the screen, you can keep pressing the download button and it will upload a new version of the program with the time frozen at the point that you downloaded it. Is that useful? Maybe somebody else can find out how this system works. I've never been able to find a live time update that keeps pace with real time once you start running your program. So much for the date and time. There is a slightly more useful feature, and I say slightly more because I'm, as you probably gathered, a bit of a cynic, and that's serial number. Time promised so much, perhaps we shall find better success with serial numbers. Now I'm going to draw a rectangle of a specified size, and that size is going to be, let's just make it 40 by 20. Now we're going to revisit something that we did earlier, which is the matrix. And we're going to select 5 in X, 5 in Y. I want you to note carefully the words here, X space and Y space. By default, you would think that they mean millimeters, so that's what we choose. And the space between is going to be 5 millimeters and 5 millimeters. And there we go, very neat. Now I'm going to go back to the text tool and click in here, because what we're going to do is we're going to use this serial number tool to try and fill those with serial numbers. Now let's quickly just read down this list. Prefix. We don't want to put a prefix on our serial number. Suffix, we don't want a suffix. Start serial number. So if I choose to put the start number at, for example, just 1, because that's where I want to start, I don't want to start it at 0, then what will happen is it will only go to 9 and then it will roll over to 0 and back to 9 again. I will only get 1 digit. Therefore I must make sure that I use as many digits in here as I need for my maximum serial number. So let's go 001. Now that will allow me to go up to 999. Then the current serial number, well, the current serial number, we'll start that at 001 as well. Now make sure you don't fall into the trap of making that 1 for your current serial number, because that will force the same situation where it will only go to 9 and then roll over. 001. The serial number increment, well, yeah, we're happy to leave that at 1. And then we're going to the extend. Now here we get the opportunity to enable a reset, which we don't need. Now if we put this ticked, enable prefix 0, because I'm going up to 999, the first number that will appear up here would be 001, then 002. I don't want that. I would prefer to just have 1, 2, 3, 4, 5. So we remove the leading zeros, and then we're going to enable the serial number array. And I've already populated this with 5 across in X and 5 in Y. We'll just take a look here again. If you remember, I made these 40 millimeters by 20 millimeters with a 5 millimeter gap. So if I put a serial number in that corner there, the next serial number needs to start here, which is 45 millimeters away. Now the reason why I emphasized millimeters, because they've actually just got the word space here. Now space could mean anything, but believe me, it actually means millimeters. So we've put this one at 45 millimeters and this one at 25 millimeters pitch. And now we've got these two strange little icons here, and we have a choice of 2 when we flip on this one. This one looks as though it reads left to right. In other words, the serial number runs across the page like that. And then we've got this other little icon here, which tells us we're either going to have the serial numbers running backwards and forwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, etc., like a snake, or we want them all in one direction, which is what I've chosen to use. So we should get what we want. OK. Apply. OK. There just seems to be a problem with this software. Every time I use it, I get the same result. It tells me where my serial number is going to be. You just saw me go OK, apply OK. Let's just click this again, and I will do apply OK. Why did it work the second time and not the first time? Okay, software bug. Now the other software bug that I can see that annoys me is it didn't tell me that I was going to work up the page, that I'd got to start from the bottom left hand corner. So I've got to physically now move this block into the right place, but there we go. So I've got a matrix of serial numbers that matches a matrix of parts. For some people this is a real world solution, for others it's not. Okay, now look, here is a practical example. Several people that I know use these laser machines for producing kits of wood for models. Maybe it's in sheets of balsa wood or possibly sheets of cardboard. They're making buildings for instance, model villages or to go with railway systems. They like to have the parts numbered up. So here's a classic example of when you would want to use serial numbers. So let's just see how would we go about doing that, because this is not an array problem. So we've got serial numbers here, and let's just say this is one of many sheets. So we'll put a prefix on, we'll put a prefix A, possibly with a dash after it. Okay, then we've got a serial number, which could be just 2 digits because we want to go up to 99. So we could just do 00. The current serial number starts off at 0. Well, that's silly because we'll start the current serial number off at 1. And then we want a serial number, then we want an increment of 1. Now, what's the point of having the extend on here other than the fact that we don't want the zeros? So we can remove the zeros. We certainly don't want a serial number array, or do we? It's not that bad a thing to use the serial number array in this particular application, even though we are not going to use the array itself. On this sheet of balsa wood or card, I think there are 9 pieces. So let's just have 5 in an array across and 2 in our array downwards, which is a total of 10. Okay, so we got the A1. Why didn't we get the array? Apply. Okay. Well, there's our serial numbers. We don't have to at least generate the serial numbers. And of course now all we've got to do is to pick that serial number up. Oh, he said we can't pick that serial number up. That's because they're all in a group. So we've got to come up here and we've got to ungroup them. And now we should be able to pick up A1 and move it to there. A2 and move it to there. So I think you can see, I'm not going to complete that example, but you can see here is a potentially useful way in which you could use the array. It's not the way in which I envisaged to make it simple, but in a practical real world you can use the array to generate a series of numbers and then you can move them around where you want on your sheet. Well, if you're as frustrated as I am, I think this would be a convenient place to stop. Take a deep breath and I shall see you next time.